Hello students, my name is Drew Donahue, pronouns she, hers, and I'm a Confluence and AmeriCorps member with the Johnson Creek Watershed Council. Today we're going to talk about macroinvertebrates. First, I will break down the word macroinvertebrate. Then I will describe what a biological assessment is and pollution affecting macroinvertebrates along Johnson Creek. Then I will describe the role macroinvertebrates have in the food web, what types of macroinvertebrates we are looking for, and how to ID them. After that, I will take you to a specific reach of Johnson Creek where I will show you how to do a macroinvertebrate survey. Finally, we will discuss what we found, determine the health of that reach of Johnson Creek, and what can be done to encourage macroinvertebrate activity. So before we dive into the specifics of macroinvertebrates, I would also like to talk about the watershed's original stewards, also known as the first peoples. The watershed was home to the traditional village sites of the Multnomah, Cathlamet, Clackamas, bands of the Chinook, Tualatin, Kalapuya, Malala, and many other tribes. Portland, Oregon currently has the 9th largest urban Native American population in the U.S., with over 380 federally recognized tribes represented in the urban Portland metropolitan area. Native Oregonians continue to be active land stewards and community members. Wisdom of the Elders is a great nonprofit that works with us and does great restoration work on Johnson Creek. So what is a macroinvertebrate? This is a pretty long word that we're going to break down to decipher its meaning. The first part is macro. The opposite of macro is micro. Many people are probably familiar with microscopes, which is equipment used to see things at the microscopic scale. So the opposite of micro is large, but not large in the literal sense. It means large enough that you can see it. So you won't need the support of a microscope to see something that is macro. The next part of the word is invertebrate. This means lacking of a spine. So a macroinvertebrate is an organism you can see with your eyes that has no spine, also known as these awesome aquatic insects. Macroinvertebrates are used in what is known as a biological assessment. Biological assessments use the characteristics of living communities, such as fish, invertebrates, amphibians, or plants, to provide data about the health of a particular body of water. Basically, just by measuring the number of macroinvertebrates living in a body of water can indicate how healthy that body of water is. This is because these types of organisms are sensitive to pollution. Just by being present in the water can tell us how polluted a body of water is because these organisms have a certain tolerance level to pollution. That is why they are known as indicator species, because they indicate this information by being present. This is important because on Johnson Creek, we have a lot of different forms of pollution. Pesticides and herbicides from agriculture, oil from cars, disturbance from urbanization, illegal dumping, and much more. So at the Council, we want to measure how many of these sensitive macroinvertebrates are present in the water to determine the health of Johnson Creek. But macroinvertebrates are not only important for their indication of water health, they also play a very important role in the aquatic food web. Macroinvertebrates may feed on living material like algae, plants, or other invertebrates, as well as on dead or decomposing plants and animals and particles of dead organic matter. They are often classified according to the way in which they obtain their food. These classifications include shredders, scrapers, collectors, and predators. Shredders are animals that wander the stream bottom looking for vegetation that has fallen into the water. Using their tearing mouthparts, they rip and shred the leaves as they feed. Shredders can be more commonly found in leaf packs, waterlogged wood, and headwater streams. Scrapers and grazers are animals that specialize on feed on the biofilm layer. That's the slimy layer you find on rocks in the creek. They use rasping mouthparts to scrape the biofilm and algae off of the rocks and vegetation. Scrapers can be found under rocks in more open areas with enough sunlight to support the growth of algae, rocks in open canopied areas, and midstream reaches. Next is collectors. These insects primarily wander the stream bottom, scavenging for dead organisms, dead organic matter, or other food particles that get lodged between rocks or in deep pools. Collectors are found in rocks and mud, common in all reaches, but make up a large proportion in lower reaches where sediment collects. Lastly is predators. They feed on living animals. Predators may swallow smaller prey whole, tear pieces out of larger prey, or suck out bodily fluids. Predators are found in all habitat types, but in smaller proportion relative to other feeding groups. But besides having important food collecting roles themselves, These insects have an important role for other species that live in the creek. Macroinvertebrates is a huge food source for fish and are particularly eaten by salmon. Johnson Creek is one of the only creeks in Portland that is home to threatened and endangered salmon that reach all the way to the headwaters where the creek starts. So this is just another reason why we want to do surveys for macroinvertebrates along Johnson Creek. So there are thousands of species of macroinvertebrates, and when doing a survey, it can be very difficult to determine the species of what you find, because most macroinvertebrates are no bigger than your pinky, and the distinguishing factors can be slight. So for the practicality of scientists who are still learning, this video will be identifying macroinvertebrates to order. The reason we can do this is because knowing the order points us towards the general sensitivity level, which is what we are looking for in our assessment. Knowing the order of a given organism we find in the creek isn't a perfect compass, and not nearly as good as keying to species, which takes more training and expertise than we can get to in a single video. We are getting a taste of biomonitoring capabilities of macroinvertebrates today, and for our survey, we want to get a general sense of what the health of Johnson Creek is, and order will be enough to determine that. So the three orders of macroinvertebrates we are going to be focusing on in our surveys are mayflies, stoneflies, and caddisflies. The reason for choosing these orders is because they are known to be sensitive to pollution. If I find a stonefly, then that means that the pollution levels in that body of water is moderately low. Remember, they are indicating the stream health just by living there. So we want to look at the orders that cannot tolerate a lot of pollution. Now we are going to go into a little more detail about each one. Mayflies are one of the more dominant orders of aquatic insects. There are over 700 species of mayflies in North America. We are going to focus on the nymph phase of the mayfly, which is shown in the bottom left diagram. Mayflies have an incomplete metamorphosis, which means there are only 3 stages. The more common metamorphosis has 4 stages, like the butterfly undergoes, which includes a pupa stage. The mayfly skips this stage, so it does not have a cocoon. So the main ID features we look for in a mayfly in its nymph stage is that it has 3 tails. Although there is a couple species with only 2, generally mayflies have 3. The flat leaf-like shaped gills and single claw at the end of each leg are also common ID features. Mayflies can be scrapers or collectors. Next is stoneflies. There are over 500 species of stoneflies in North America and also have an incomplete metamorphosis just like the mayfly. Stoneflies can vary greatly in size, from ranging just 1/4 of an inch to well over 2 inches long. The main ID characteristics of stoneflies in their nymph stage is that they only have 2 tails. They also have 2 claws at the end of each leg, and their gills are usually on the upper abdomen or under their arms. These finger-like gills kind of look like hairy armpits. Stoneflies can be predators, shredders, scrapers, and collectors. Lastly is caddisflies. These insects have adapted to nearly all aquatic environments, and there are over 1,200 species in North America. Because of their wide range, they also have different sensitivity levels, but we are just going to focus on the more sensitive ones. Caddisflies have a complete metamorphosis and have all 4 stages, including the pupa stage. Their main ID features include an anal hook at the end of their abdomen instead of a tail, and very small antennae that are often invisible without a microscope. Another really cool feature are these portable cases that are made from surrounding materials that cover the caddisfly larva in a small portable house. They are really incredible and can be made up of all kinds of materials. Case-building caddisfly larvae are the ones we want to focus on because they are sensitive or intolerant to pollution. So look out for net-spinning caddisfly larvae. These caddisflies don't make cases and kind of look like they have a tuft of hair on the end of the abdomen. These caddisflies are tolerant to pollution, and their presence indicates that there is likely organic pollution in the creek when they occur in large abundances and when there is a small amount of other macroinvertebrates present. Caddisflies can be predators, grazers, collectors, and shredders. Some other species you might find along Johnson Creek are snails, pictured on the top left. Snails with an opening to the left are considered tolerant to pollution, so they can handle quite a bit. Another is water striders, pictured on the bottom left, which are also tolerant. Crayfish, which is pictured on the bottom right, are somewhat tolerant of pollution. Our native crayfish, called the signal crayfish, is identified by the white dot near their pinchers. And another common species you might find is freshwater clams, pictured on the top right. These are also somewhat tolerant. Even though mayflies, stoneflies, and caddisflies are our target species, it is still important to write down what you find. If we find none of the target species, then we can still make an assessment based off of what we did find. Before we jump into our demonstration portion of a macroinvertebrate survey, I want to mention the best places to find these organisms. Different macroinvertebrates like different habitats, so they can be found just about anywhere in the creek. I mentioned rocks in open canopied areas, waterlogged wood, leaves, and a couple more earlier in the video, and these are all great places to look for them. But another great place to find macroinvertebrates is in riffles. These are shallower areas with medium to fast current, where the flowing water breaks and churns over mixed gravel, cobble, and boulders. An example of a riffle is shown on the bottom right. You can usually tell where a riffle is because there's a lot of white in the water, which is the bubbles being created by the water hitting the rocks. Riffles are some of the best sampling microhabitats because they contain the greatest diversity of macroinvertebrates, are the most likely place to find pollution-sensitive species, have fairly consistent habitat throughout the riffle, and contain cooler water and thus higher dissolved oxygen. Many of the sensitive species I mentioned earlier prefer cooler waters just like salmon do. Macroinvertebrates can be found any time of the year, but most appear during the summer months. Now I would take you to Leach Botanical Garden near Southeast 122nd and Southeast Foster, which is nestled on Johnson Creek, where we will be doing a macroinvertebrate survey demonstration. Hello students, we're here at Leach Botanical Garden, and we're going to do the demonstration portion of our macroinvertebrate survey. I brought with me Marissa, who's going to be our lovely assistant, and she's before we dive into the survey, we're going to go over the equipment we're going to be using. So she's actually holding our first piece of equipment, which is called a D-net, and the reason it gets that name is because of the D shape it has at the top. So it has this flat kind of part at the top, which is important with your nets because we want it kind of level with the creek when we're doing our survey. We also want nets with kind of this more fine mesh on it, so that way some of the smaller macroinvertebrates don't seep through the cracks there. So then our next piece of equipment is going to be a white tub here. And so usually you want a white tub so that way you can see the macroinvertebrates better. So after you catch your macroinvertebrates in the net, it's going to go into this tub. So then after that, our next piece of equipment here is a turkey baster and kind of just like a deep spoon. So you're going to use that to transfer the macroinvertebrates into your other piece of equipment, which is the ice cube tray. And the reason you want to do that is so you can see your macroinvertebrates better for ID. The turkey baster you want to use for the smaller ones, and the spoons you'll use for the bigger macroinvertebrates. So then we also have a magnifying glass. This one right here is actually a two-way magnifying glass, so you can see from the top and the bottom. So that way if we have those really small ones, we can kind of look at them better, you know, count how many tails they have, for example. So then our other piece here are ID guides. So while we're closely looking at our macroinvertebrates, we might need some help from our guides to find their identifying features. And lastly is going to be our data sheet. So as we identify our macroinvertebrates, we're going to want to write down what we find so that way we can assess the health of the creek later. So that's the equipment we're going to be using today. So now we're going to jump into the demonstration portion of our video. All right, now we're going to do the survey portion of our demonstration. So we're going to get in the creek here. Anywhere in the creek is fine. We're kind of like in the middle of the riffle. And then Marissa is going to take the net and kind of just like wiggle it into the ground. You kind of want to get it buried a little bit when you do your collection. And you also want the water flowing into the net. So now I'm going to take some rocks nearby and I'm going to kind of like scrape them off into the net a little bit. This can also be known as like scrubbing a potato. So macroinvertebrates are known to live under the rocks. They really like that area, so we're kind of just trying to knock them off into the net. Another way you can do this is also take your foot and gently just kind of stir up the sediment in front of the net. So that will also kind of knock some off into the net. All right, after you've done that, we're going to take our net with our findings and we're going to go dump it into that white bucket. Yeah, so we'll just gently shake the net, trying to knock them off into it. You can also take the turkey baster, kind of get some water and just kind of gently put the water over it. But yeah, just kind of knocking them off the best you can into the bucket. All right, let's see what we found. So go ahead and take a look in there. So macroinvertebrates will probably hold still for the first time you put them in the bucket, and then they'll start to kind of move around as they settle down. We also got a leaf in there. A lot of macroinvertebrates like to live on the vegetation as well. Alright, so let's see what we got in this bucket. So over here we have a freshwater clam right there. And then let's move some stuff around. Oh, right here we have a crayfish. Right there. Here, I'll touch him, so there he is. And then, let's see what else we got in here. Oh, so this guy here is the casing to a caddisfly larva. So he's probably in there. He's probably a little scared, but he's made the casing from the surrounding rocks in this stream. Great. So, earlier we did a survey for about half an hour, and if you'll pan over to the ice cube tray here, these are some of the things that we found. So again, freshwater clam. Here we got the crawdad, or also known as crayfish. Here is another caddisfly larva. Here we have a worm that we found. Lots of snails that we found. And then it's a little harder to see, but there are some mayflies in here. So with mayflies, I believe there's one in this one right there, that little guy. There's also a beetle floating up top, but right there is a macroinvertebrate. That is a mayfly because it has, if you can see it, the three tails on it. Great, so that's kind of what we found at our survey here at Leach Botanical Garden. Now we're going to go to the results section of our video. So what did we find during our 30-minute survey at Leach Botanical Garden along Johnson Creek? We found macroinvertebrates of all sensitivity categories. We found 7 mayflies, 2 case-building caddisfly larvas, and 1 riffle beetle in the sensitive or intolerant section. We also found 2 crayfish, 3 freshwater clams, and 1 fingernet caddisfly larva in the somewhat sensitive section. We found 1 net-spinning caddisfly larva, 1 aquatic worm, and 8 snails in the tolerant section. So this is what your data sheet is going to look like. I have filled in the number found for each sensitivity section. Notice that we found 2 macroinvertebrates that are not included on the data sheet, the somewhat tolerant fingernet caddisfly larva, which we did not cover in this video, and the tolerant net-spinning caddisfly larva. Sometimes you discover new things that is not on your data sheet, and that is awesome. Sometimes it can be confusing, but it's exciting to see something that you weren't expecting. So I went ahead and added a small section to the side to account for these 2 macroinvertebrates. If you also find something on your survey that is not included on the data sheet, go ahead and do the same, because that's still important data even if you weren't expecting it. There's another part of the data sheet that hasn't been filled out yet. These are the sensitivity scores of the categories and will help us determine the health of this reach of Johnson Creek. These scores use the HILSENHOF BIOTIC index to determine the pollution levels. So macroinvertebrates with a score of 1 are very sensitive to pollution and the water quality will most likely be healthy. Those with a score of 8 are pretty tolerant to pollution and the water quality would most likely be poor. So for this data sheet, this index was simplified into 3 categories. The sensitive species with a range of around 0 to 4 was put into the sensitive category. Those in the sensitive range will score a 3 if present. The somewhat sensitive species in the 4 to 8 range will score a 2, and the tolerant species in the 8 to 10 range will score a 1. So if I found one of the organisms listed in a category, I circled the score next to it. I then added all of the numbers circled in each sensitivity category. So the sensitive category scored a 9, the somewhat sensitive category scored a 6, and the tolerant category scored a 3. On the bottom right is where we'll use these numbers to determine the health of the water. So when I added up those totals from each category, I get 18, which falls into the 17 to 22 category, which means that the health of this reach of Johnson Creek is good. This is a pretty solid score, and it means that the creek is healthy. One thing to keep in mind is that we found 2 of the 3 target-sensitive species in this part of Johnson Creek. These 2 macroinvertebrates have an HBI score of lower than 4, which means by just being present in the creek means that the pollution level is fairly low. If this reach had high levels of pollution, then we wouldn't have found any at all. In fact, Johnson Creek has been seeing rising macroinvertebrate levels, showing that the health of a very populated creek is slowly becoming more healthy again, and we are very excited to continue this research. Another important thing I want to mention before we end the video is that if you choose to do your own survey, you are participating in community science. Macroinvertebrate ID can be hard, and as a community scientist, you are not expected to be an expert. In fact, I had an expert look over this video, and the freshwater clams we found are invasive Asian clams that are very tolerant to pollution, not in the somewhat sensitive category I had put them in. Even though I had made a mistake in ID, if I had gone back and recalculated the sensitivity score with clams in the tolerant category rather than the somewhat sensitive category, I would have still had a final score in the good category. Rather than 18, it would have been 17, still showing that the health of that reach of Johnson Creek is good. Your data is still really important even if there are some misidentification. Just by getting a general idea of how healthy your water is important work and can tell us the direction we need to take in restoration efforts. Thank you so much for watching Johnson Creek Watershed Council's Macroinvertebrate Survey video. If you have any videos you would like to see in the future, please email the email provided in the comments. We also provide field trips, which includes macroinvertebrate surveys. See details below. Thank you again and enjoy this small close-up video clip of a mayfly we found during our survey.